this is A, B, C. So there's a test. These two are moving with a velocity V. Okay, there's the initial, and they are lying on a horizontal surface. So first, the B will come and collide. The moment they collide, they will have common velocity. I'll read the question. I'm trying to construct overall the sequence. All are having same mass. Every time I need to indicate mass, it'll be like this. Then in next sequence, finally all will have common velocity. Okay, there's an overall condition. So if you want, you could, no need to draw a diagram, or the last, this diagram is very important. Unless we don't have this, we cannot solve it. These are overall, the problem demands a student has to have this much of imagination, is what I'm telling. You must have this much of imagination. Okay, at least I'm helping the diagram. Looking at the diagram now, you get into the problem solving. Okay, first plate, the plates B and C, board, or say what is saying board, the board B and C will collide. Okay, we'll come to the second and third diagram. So can we apply conservation of linear momentum to get V1? Shall we apply conservation of linear momentum to get the V1? So applying conservation of linear momentum, initial momentum equal to final momentum. So based on that, 2mv equal to 3mv1. So v1 equal to 2v by 3. Okay, this is something very important. After this, the final speed of each board is 2v by 3. Okay, take this one. Next, what is the work done? Total work done. Look at the final contingency. Will it be less than or greater than initial contingency? Will be less than. So initial contingency will have final contingency will be 3 by why 3? Because finally all will have same contingency. So this is the final 3 by 2 m This will be 2mv square by 3. Look at final. I think it is in fact less than initial. Where do this difference in kinetic energy converted into work done to overcome the friction? So therefore, as work done by friction equal to delta K, Ki minus Kf. This should be mv square 2mv square by 3. Or you write Kf minus Ki, so you'll get negative, means work was
So that is mv square minus 2 by 3 mv square.
mv square minus, no, change in kinetic energy, so Kf minus Ki mv square. Three by, is it okay calculation? So this is the negative sign, it will come. Okay, no. So this is the work done. So he's asking, there's a net work done by friction. It is this quantity net work done by friction will take it. Total work done by friction force on C is telling, only on C. What was the initial kinetic energy of the C? It was attached. Finally, it is moving with. So work done by frictional force, there's a net work done. Work done by frictional force on C will calculate. That should be equal to change in kinetic energy of m v1 square. M by 2. V1 is how much? 2v by 3 whole square. So this will be 2mv square by 9. It does positive work on the block C. So what is this? Work done by friction on board C. There's a net work done by friction. This one. So the speed of final speed of each board is 2v by 3. Okay, there's no problem. Okay, we ended up this one. The total work done by frictional force on the system is 0. Okay, this is ruled out. So what all we have, I put it. Now he's asking length of the board. From where the length of the board I can bring? How to bring length of the board? It's the next part of the discussion. For that, let me take help of this diagram. So here, let this have just after collision. So this will be V and V by 2. No? So here in the y direction, the friction will act on A, and on this combined these two, it will be in this direction. The net work done by friction is what we have. Net work done by friction is what we are having. So after getting the net work done by friction, no, we know net work done by friction. And other side, what will happen? I know work done by friction, I'll calculate here. By equating this, I can bring the length. Is this calculation, check it once. Am I right?
Yes,
Net
sir.
work done by friction. Okay, yeah, then we'll proceed here. No. No, how to calculate the work done, net work done by friction with the help of, we have to bring this L into the picture. Friction does negative work on the block A and it does positive work on the plank C. What about the normal contact here? This is N, this MG, no? So what all that friction acting? Let's get into the calculation part. Work done by friction, this should be equal to,
How many
it
OMG,
does
sir? There are two normal contacts, sir. One between A and B, one between A and C, and the friction is only due to the normal contact between A and C, no, sir.
Sorry. This is variable. Huh? This is. I'll bring into the picture. So F is equal to, it does negative work on the block. A friction will be acting this one, and it does positive work on the block C. So this will become F into D of XC minus XC. No, I think, okay, yeah, we'll keep this much of diagram. How to bring this particular part. So let me define the normal contact, because some XA length of the plank is on B and some XA length is on plank C. So let me define lambda. Lambda is mass per unit length. So shall we define now the normal contact is equal to lambda into XC minus XA into G. What all normal contact is, some part of A will be there on B and part of the length of board A will be there on C. So that XC minus XA is what we'll write here. So what is lambda? Lambda is M by L. This XC minus XA, let me call that as say some X. It will be easy for us to analyze things mathematically. So this will become F equal to mu n into dx. Mu, so this will become, I have to go for next page, or I'll write here in the corner. This should be equal to, substituting F, this will be integral of m by L gx into dx. Mu should be there, no? Mu n. One more step, I'll write it. Mu n into dx. So mu into n will be m by L x g into dx. So this will be mu g m L. Now what's with the limit? 0 to L. Mu mg L by 2 will come. So we know other side, the net work done by the friction, substituting that, we'll get expression for this one. So there's the equation 1, I'll write it. I'll go for next page. So this will become mv square by 3. So length of the plank will be 2v square by 3 mu g we are getting.
Why did you equate with mv square by 3, sir?
There is a network done by friction. No? Friction does negative work on the plank A.
First, inelastic collision takes place, no, sir.
Because of that, the relative motion, friction will act. No? And the moment as it starts entering again,
There is no friction
motion
between A and B, no, sir.
No, this friction is what that I'm showing it here. I'm unable to show it here. There's a friction between A and C only. It does negative work on A and does positive work on C. There's no friction between A and B. This is what the distance x. For this normal contact rod pen, only this part of the weight has to be taken. That's why we have broken up things like this here. Okay, but somewhere we are getting.
How can we take directly net changing kinetic energy, sir? From the initial to final state, how can we take kinetic energy changes work done by frictions?
Oh, some energy is lost during collision, no?
Yes, sir. So from the second,
The second
yes,
diagram, I'll go.
sir, from second diagram and third.
Initial kinetic energy. Yeah. Final speed of the each board, I think that is no problem. Okay, that I had to put it. Okay, I got it now. So KF will be, I think to calculate this, let me call K dash. Okay, here I'm going wrong. Yeah. I should start from second diagram, no? From here. What is this kinetic energy? MV square K dash will calculate. K dash will be MV square by 2, 2 MV by 2 whole square. MV square will come. Fine. Okay, this MV square. Okay,
2m by 2, v by 2.
1 by 2 will be there. 1 by 2, 2. This will be 1 by 4. Huh? Yeah, 1 by 4 will be there. So this will be 3 by 4. Here 3 by 4. Anybody value? 4 to 8. 8 minus 9 by 12 will come. Yeah. Oh. Check once. I think I should. There's a network done by friction. MV square by 12. Okay, now we'll equate here. MV square by 12. How much will get it? 6 will come. Okay, we'll check the options here. If you want any other method, you can apply. I felt like conservation of momentum little bit. If you take it, no, it'll be easier for us. Okay, this K dash, you remember K here, huh? Because some energy lost during collision that has to be taken care. You see that what we're getting, the length of the plank depends on mu. Is it justified, or it's only numerical relationship we brought it? If I change length of the plank, well, mu will change. I wanted to just interpret this. Is it like that? No, this is some sort of numerical condition. It is not like something like if you change length of the plank, mu will change. Mu is what? Property of surface, no? So we should not conclude in that way again. Again, if you change length of the plank, okay, for again, it may not be in this position. It may be somewhere here or before reaching totally on C, it may some length of like a plank A, what happened will be there on B. It can happen, but don't conclude in this way again. By changing length, the mu will change. The mu is a property of two surfaces. Doesn't depend upon the physical length. Okay, I think this will be very dangerous. Huh? So don't relate anything L and mu. Okay, I'll take the next one. You read, I'll adjust these things.
Sir,
Ah.
we wrote it as net changing kinetic energy of C as work done by friction on C now, sir.
Friction does negative work on plank A and does positive work on plank C. That's the meaning, no?
Yes, sir, some energy is lost during collision now, sir.
So
Taking from the initial to final state.
no, this one K dash, that's why I replaced, no?
That one, sir, work done by friction on C.
Oh, this also work done by friction on the C should be, the plate C was at rest, no? You
Yes,
see
sir.
that one. The plate C, it is having velocity V by 2.
During collision, there is no work
that
done
one.
by friction.
Okay, this one. I think I forgot this one. No? Okay.
Yes, sir.
I think that collision one I'm totally forgetting. There's also some correction is needed because collision occurs. I'm trying to totally forget that collision. Collision occurs after collision V by 2. Now the friction will act into picture. Yeah, fine. This how much will come then? This will be here it will be mv square by 8. So for this we'll subtract mv square by 8. Mv in anybody value?
Seven
7 by
MV square.
72.
7 mv square by
22.
72, sir.
72.
Sir, how did you got K dash, sir?
K dash is the kinetic energy. K dash is mv square plus mv by 2 whole square plus mv by 2 whole square. That's why the 2 is brought here.
Okay, sir.
K dash is for total. This is for total. I think I'll not for one plate, for total it is. Okay, I think that collision one, I think we are like how I forgot, no, it may happen for you also. In between some collision occurred and there is some energy is lost during collision. I think let me write that comment somewhere here. Some energy is lost during collision. That will write it here. So that will be more useful for us. Some kinetic energy is lost during I think this is something very important for us because neglecting this will have a lot of impact on the problem, or answers will go wrong. Almost all answers will go wrong. I think such questions can be asked in advance. It's a simple idea based. Okay, we'll take the next one.